mountain in front of you. And the angle of elevation looking up to the mountain is 3.5 degrees. You travel 13 miles, getting closer to the mountain. Now, when you look up, the angle of elevation is bigger because you're closer to the mountain. That's 9 degrees. What is the height of the mountain? Dealing with this set. You want the height of the mountain, h. All you know is that this distance is 13 miles. And that's all you have. Okay? Right up until now, all we know is SOHCAHTOA. That's it. That's all we get to use, SOHCAHTOA. If we knew what this distance was, we'd be done. Because if we knew what this was, it's just you have the angle, you want the opposite side. If we knew what this was, opposite and adjacent is tangent, and we just use tangent of 9 degrees instead of an equation, that we can solve for h. But we don't know what that piece is. But I need it. Oh gosh, we need it. So we can call it something. We can call that x. So what you have is a right triangle. And I'm just going to slip it out of the picture right there. And obviously not the scale. 9 degrees, you've got x, and that's h. The other right triangle you have is the 3.5 degrees and the 90. If you knew what the total distance was from where you started to the center of the mountain, then you could have used that right triangle. You want the opposite. If you knew what the adjacent was, the tangent of 3.5 degrees is equal to that h over the adjacent. Well, this adjacent, since you labeled this x, this adjacent can be labeled from here to there. I know it's going to kind of look a little bit weird, but it would be 13 miles plus x miles. So let's just call it x plus 13 miles from here to here. So on the other triangle, 3.5 degree elevation, you still want h, and this adjacent side is x plus 13 miles. Sometimes it's necessary to separate the picture from, take the two triangles out of your picture so you can actually see what you have to work with. If you don't need to, you're solving for h. Well, I'm sorry, but you ain't going to get to h with one equation. This is what you know. The tangent of 3.5 degrees is equal to the opposite h over this x plus 3. Right there, we got it wrong. Which means if you got a denominator, if you multiply both sides by x plus 13, don't forget to use parentheses, x plus 13 parentheses, then over here, the height of the mountain is x plus 13 times the tangent of 3.5 degrees. So if I knew what x was, I could plug in right here, multiply together, I have a amount. I don't know what x is. I have two variables, h and x. H and x. When you have two variables, you're gonna need two equations. When you have two unknowns, you're gonna need two equations. Because what you're gonna do is you're gonna make some substitutions and get rid of one of the equations, so you have only, one of the variables, so you only have one variable left. Then you solve it, and then you can figure out what the other variable is. When you have two variables, you need two equations, so you can either let them equal each other, make a substitution, do some kind of, the elimination process, solve for one of the variables, and then you plug it in and find the other. So that's one way to figure out h. In the other triangle, the tangent of 9 degrees is equal to the opposite h over x. Multiply both sides by x. So x times the tangent of 9 degrees is equal to h. Well, that's a lot nicer one. But again, I don't know what x is, so I don't know what h is. Over here, I don't know what x is, but I don't know what h is. The good news is the height from way back here of the mountain is the same as the height from right here, 13 miles closer. So these two heights are the same. The two heights are equal to each other. That means that the two heights are equal to each other, then this x plus 13 times the tangent of 3.5 degrees is going to equal to x times the tangent of 9 degrees. I can now write an equation with only one variable using the two equations that I made. Now, are you supposed to just know how to do that just because you just showed up one day and you've always been good at math? Maybe. But most of the time, no. So what are you supposed to do? I've seen something like it now. Now you got to start to file it away. You've done problems that were process of substitution when you did algebra 2 or algebra 1. Equations, two variables at a time, you have to do the elimination method, substitution method, and you solve for ordered pairs. What are the values of x's and y's that make both equations true at the same time? You've done them before, if you took algebra or algebra 2. Now here's a word problem that uses the same process, and you don't even know it, but that's what you got to do. You've got to come up with some kind of equation that relates what you have with what you want. I have 13 miles and a couple of angles. I want the height, which is the opposite side of a right triangle to those angles. Opposite, the 13 miles is an adjacent. Opposite, adjacent, I'm thinking tangent. So I'm going to use tangent to put the pieces together. Okay. So now, I'm not going to do decimals yet. I will do decimals in a minute because I'm going to, it's simpler to just substitute or distribute like this. This is x times the tangent of 3.5 degrees plus 13 times the tangent of 3.5 degrees equal to x times the tangent of 9 degrees. Yeah, we can go decimal at any time, but I'm just going to wait. Okay, now that's got an x in it. This doesn't. This is just a number. That's got an x in it. When you're solving an equation, if you have x plus 2 equals 4x, the next step would be get all your x's on one side. Either bring the 4x to the left and take the 2 to the right, or in this case, you'd probably just subtract x from both sides and you get 2 equals 3x. Get all your x's on one side and solve. Same thing here. That's x times the tangent of 3.5. That's x times the tangent of 9. So I'm going to take my x's to the right-hand side. So I have 13 times the tangent of 3.5 degrees equal to, now, you don't just go 9 minus 3.5. It doesn't work that way. It's x times the tangent of 9 degrees minus x times the tangent of 3.5 degrees. It's not, the tangent, let's do this. The tangent of 60 degrees minus the tangent of 30 degrees does not equal the tangent of 30 degrees. It doesn't. Because you know the tangent of 60 based upon what we've done already. 60, okay? This is my 60-degree angle. So that's going to be square root of 3 over 1. You flip it over. If you haven't practiced your little hand movements. So this is square root of 3 minus, if that's the square root of 3, the tangent of 30 is the other one, 1 over square root of 3. And this is equal to 1 over square root of 3. I don't think we're going to get it. Square root 3 over square root 3 is common denominator. That's 3 over square root 3 minus 1 over square root 3. 3 minus 1, 2 over square root 3 equals 1. I don't think it equals. So you can't just go 60 minus 30 positive. You can't just go 9 minus 3.5. So you will. Good. So let's calculate. Make sure your calculator is 10 degrees. You gotta get your calculator in the mode, or in this case, you gotta get your calculator in the mood. So the tangent of 3.5, make sure I'm degrees. Yep. So the tangent of 3.5 so I'm going to write it out. Over here, this is 13 times 0.0611 626 202 is equal to, now, I still need to take the tangent of 9 degrees, but over here, it's going to be minus x times the tangent of 3.5. So it's going to be 0.0611 626 202 x. Because that's my tangent of 3.5. The tangent of 9 degrees right here. And my tangent of 9 the tangent of 9 degrees is 0.158 384 4403 times the x. So since I already have this in the calculator right here, this decimal minus the last decimal, because it's basically 0.15838 minus 0.06116 x's. Basically, it's the tangent of 9 minus the tangent of 3.5. So I'm just going to go the last answer minus the tangent of 3.5, and that's, I don't have to do a lot of, actually typing in the decimals. I'm just going to write minus the tangent of 3.5. But I'm showing you my work because that way everybody's following what I'm doing. So this answer is my tangent 9 minus the tangent of 3.5, and we get 0.09722182202 x's. And on the left-hand side, I'm going to do it clear so I can move this thing up. 13 times the tangent of 3.5. 13 times the tangent of 3.5. So 13 times the tangent of 3.5 is 0.7951140062. So now to solve for x, you divide both sides by 0.09722182202. Yes, you should be using all these decimals because you need to be accurate and you round at the end. And we get x equal to 8.17 414 602. And this is what usually happens. All right, yes, I got the answer. And then you go to the back of the book, right on. I'm going to check my answer in the back of the book because I got the answer. I go to the back of the book. Where the heck is the back of the book? Out of the book, out of the book, and out of the book. Oh, yeah, there it is. 9.2, down to 81. Okay. 1.3 miles. I have 8.1. Wait a second. The mountain's 8 miles high. Yeah, my angle of elevation probably should have been a little higher if it was need to be realistic here. I shouldn't have gotten so excited yet. I didn't solve for what I was supposed to solve for. What am I supposed to solve for? H, not X. Supposed to figure out what H is, not X. Oh man, we're looking for H and X. I was going to a corner trying to buy some stuff. Wow, that ain't even like not even a giggle. Not even, maybe you're smiling under the mask. Or maybe you don't want to give too much away about yourself. I don't know. Go back to here. Remember what you got. I'm just making some room. Over here, you have H equal to x plus 13 times the tangent of 3.5 degrees. You also have H over here equal to x times the tangent of 9 degrees. Out of those two possible ways to solve for H, which one is the simplest? 3.5 degrees or the 9 degrees? The 9. Because over here, if you use the 3.5, you got to add 13 again, because I would get it wrong because I keep putting the 3. You have to add 13, and then you multiply by 3.5. Tangent of 3.5. Here, it's just the height is supposed to equal the x that we found, 8.17414 times the tangent of 9. And the tangent of 9 was right here, times 0.1583844, 0.03. But what I'm going to do on the calculator is I'm just going to press the last answer times, so that last answer times
Divided by 0.09727 is 0.09722.
0.9. Okay, so that X is off, because I'm trying, I actually have to type that in. No, that's okay. I'd rather make sure the thing's right. So. No, it will. It's 13 tangent 3.5. 13 times. I took off my glasses, look at the glasses, I can't see the other glasses. So. 1. That one, divide by, I'll type this in correctly this time, 0.9722 182 02 0.0. That means I just gotta go over here to the left. And insert. Second, insert another 0. And then 8.17. So it throws it off at the thousandth place. Eight point 178349884. Now I'm going to take this and multiply times the tangent of 90 degrees. So the last answer times a tangent of 9. And we get h, the height, is equal to 1.295323369. Unfortunately, the problem doesn't tell you what to round to, and that's what I don't like about the way the book writes it, but we rounded to 1.3 miles. Okay. But it does take 2 equations with 2 variables to solve it. Some gifts. Or the ground jet. Oh, this actually gifts. Posted the identities, but I also went ahead and made copies of them. So in case you didn't see the email or download it, here's a copy of it. And we've done everything except the very bottom. Everything but the very, very bottom. Which is what's going to happen today. 5.3. Okay. So far, our trig functions, our trig ratios have been confined to a right triangle. We've only been able to take the sine, cosine, and tangent of acute angles. We haven't been able to do 0, sine, cosine, or tangent of 0. We haven't been able to do sine, cosine, or tangent of 90. We've only been able to do any angle between 0 and 90. You know, when you try to go like this, you go to a calculator, you go, hey, I'm curious. Siri, what is the tangent of 90 degrees? And it says, bite me. Okay, Siri, don't get surly with me, Siri. But it's not in the domain. 90 is not in the domain of tangent. Domain means what are you allowed to plug into it? Well, you're not allowed to plug 90 degrees into the tangent function. Why? Well, now take this perspective. We're going to broaden our horizons, and we're going to open it up to any angle, positive, negative. We're going to open it up from 0 to an infinite number of degrees, to a negative infinite number of degrees, to an infinite number of radians, negative infinite number, any angle you want. Whole bunch of times around, either way. And you're going to see something happen. But we're going to change the definition. If you put it on the XY axis, I know that. I talked about this. When you look at the circle, draw the circle first. And you put your triangle like that on your circle, then this point on the triangle, the ordered pair, is some X and there's some Y. It's some X, some Y. Now the circle has, as all circles do, they have a radius. This is the angle theta in standard position on the circle. You can't make sine, cosine, or tangent unless you have a right angle. You can always make a right angle if you just take this point and go perpendicular to the x-axis. So you're always going to be able to generate a right triangle from that point. Now, from theta's perspective, the opposite is the y value because it's the height of the point. The adjacent is left and right, so that's the x coordinate. So as we would usually say that the sine of theta is the opposite over the adjacent, sorry, opposite over hypotenuse, like that, opposite over hypotenuse. In this triangle, in this circle, the opposite is y and the hypotenuse is the radius. By definition now. The opposite is the y value. I'm going to throw a word in here that we don't use. We don't throw this around very much in mathematics. The opposite is the y value. Always. Always. The sine is y. The sine uses the y. The hypotenuse will be the radius. Always. The cosine, which we would like to go with adjacent over hypotenuse. And adjacent to theta in a circle scenario is the x coordinate. Is now x over the radius. So the radius is going to be your hypotenuse always. No matter what, always. And now you know you can make tangent theta out of sine over cosine. But you can just go straight to, tangent theta is the opposite over the adjacent. And the opposite of theta in the circle scenario is the y, and the adjacent is the x. But even if you did tangent theta was sine theta over cosine theta, the sine is y over r, the cosine is x over r. If you're taking y over r and dividing by x over r, that means you're taking y over r and multiplying by the reciprocal, which is r over x. And the r is reduced, and you end up with y over x anyway. There's absolutely no way to get it wrong unless you just set it up. It will always work out, provided you put them in the right place. So you got to know the right places. Okay. So now, with these two definitions in hand, the sine of theta is equal to the y coordinate over the radius of the circle. The cosine of theta is equal to the x coordinate over the radius of the circle. And the tangent of angle theta in standard position is equal to the y over the x. Now, the radius can never equal 0. Because if the radius did equal 0, you wouldn't have a circle. You would just be sitting at the origin and you don't have an angle either. So the radius can never equal 0. But x and y can equal 0. Because they can be any point on the circle. So right here, when you want to do the tangent of 90 degrees, when you have an angle of 90 degrees, I don't care how long the radius is. You have x is a 0 when you're on the y-axis. For 90 degrees, x is a 0 because the angle terminates on the y-axis. And y is whatever y is going to be, because y could be 10, it could be 5, it could be 1, it could be net, it could be whatever. Not negative, that's going up. But it could be whatever. So the tangent is y over the x. Well, the x at 90 is always 0. It's going to be divided by 0. And that means the tangent of 90 is not going to happen. It's going to be undefined all the time. X cannot equal 0. Okay. That's why we can't do the tangent of 90. This also is going to happen for our reciprocal functions. The reciprocal of sine, cosecant theta, you just flip this over. The radius over the y. The secant of theta is the radius over x. And the cotangent of theta is going to be x over y. Now we know the radius is never going to equal 0, never. But x's and y's can equal 0. So when you flip over sine and you get cosecant, now you have y in the denominator. So you need to be aware that if y equals 0, you're going to get undefined. So y can't equal 0. If you have a sine of 0, if the sine of theta is a 0 and you try to flip it over, you now have a cosecant that's undefined. For secant, if the x coordinate is a 0, like it is right here at 90 degrees, if x is a 0, then the secant is going to be undefined when you flip it over. The x better not equal 0. And cotangent, well, down here is y. So if y is a 0, then cotangent is undefined. So if your tangent equals 0, then the reciprocal of 0 is undefined because y is at the bottom. Y better not equal 0. So there's some restrictions as you go around the circle when you're on the axes, because that's the only time x's and y's would equal 0. Okay. Over here, when you're here on the x-axis, the y is a 0. Up here, when you're on the y-axis, the x is a 0. Over here to the left, the y would be a 0. And down here, it's on the y-axis, so the x would be a 0. So that's where you're going to have your undefined. It's also where you're going to have some zeros. Okay. Now when we do something like what's the sine of 150 degrees? Well, 150 is bigger than 90. It's not going to make a right triangle. So 150 degrees right about here. By definition, the sine of 150, what you need to know is what's the y and what's the r. That's how you make it. So what I'm going to do is I'm going to make the radius equal to 1. If that's 1, then what you just did was this. If this is 150, then right here is 30 degrees. Which means when you draw the right triangle in quadrant 2, there's your 30, 60, 90 right triangle. If the hypotenuse is 1, then over here the short leg is 1/2. And the long leg is square root 3 times the short leg. This long leg would be square root 3 over 2 as a length. But here's the deal. All you care about is the sine. The y value is 1/2. The radius is a 1. 1/2 divided by 1 is just 1/2. For 150 degrees, the sine is 1/2. The cosine of 150 degrees is the x value divided by the radius. Now, this is where it gets to be fun if you do it right. First thing you got to think of, pluses, minuses. Because it's based on coordinates. When you go to the left, x is negative. So the length of the triangle is square root 3 over 2. So the x coordinate is negative square root 3 over 2. But because it's in quadrant 2, it's up. The y coordinate is positive 1/2. X is negative if you go left, y is positive when you go up. So the cosine is going to be a negative square root 3 over 2. And the radius is a 1. Negative square root 3 over 2 divided by 1. The cosine of 150 is negative square root 3 over 2. Signs matter. What matters is what quadrant are you in. Now, gonna be a lot to memorize if you gotta go all the way around for all these angles. This is what I kept talking about over the last couple of weeks. 30 degrees right there, 30 degrees right here in quadrant 1. In quadrant 1, if this is 30, then when you make the right triangle and the radius is 1, the opposite side would be 1/2 and the adjacent side would be square root 3/2. So this order pair would be positive square root 3/2, positive 1/2. The exact same numbers, but because you're in quadrant 1, they're both pluses. Over here, the x is negative because you're going to the other side of the origin. So if you know what happens at 30, you know what's going to happen at 150. If you know what happens at 60, because at 60, the x is 1/2 and the y is square root 3/2, then you know what's going to happen at 120. At 120, x is negative, negative 1/2. Y is still positive, square root 3/2. And if you know what's happening at 45, x is square root 2/2, and y is square root 2/2. Then in quadrant 2, it's x is negative square root 2/2, but y is still a positive square root 2/2. When you have 135, the coordinates are the same, signs are different. This depends on what quadrant you're in. If I go to quadrant 4 and I do 315 degrees, or 7 pi over 4 radians, what's the x and y? What would the x be? If I'm here, x is going to be positive square root 2/2, and then the y would be negative square root 2/2. Because it's down. Okay, so here we go. All right. I'll make sure I don't get too far ahead of myself. So let's just think of it. In quadrant 1, the x coordinate is a positive, the y coordinate is a positive. In quadrant 2, the x coordinate's a negative, the y coordinate's a positive. In quadrant 3, both coordinates are negative. X is negative, y is negative. And in quadrant 4, x is a positive, y is a negative. Okay. In quadrant 1, and by the way, the radius is always positive. It's always greater than 0. Because if it's, you can't have a negative length, you can't have a 0 length. The radius is always a positive number. So when you go sine y over r, cosine x over r, tangent y over x. That's a positive over a positive. So sine is positive. Cosine is a positive over a positive. Cosine is positive. Tangent would be a positive over a positive. So tangent is a positive. So all three trig functions all three of them are all positives. All of them are positive. When you get into quadrant 2, sine theta would be y over r. Cosine theta, again, is x over r. Tangent theta is y over x. So in quadrant 2, y is a positive and the radius is a positive. So sine would be a positive. Cosine though, in quadrant 2, x is a negative and the radius is a positive. So cosine is negative. Tangent, y over x. The y is a positive, but the x is a negative. Tangent has opposite sign, y over x. So tangent theta is a negative. So the only positive trig function in quadrant 2 is sine. They're all positive here, and only sine is positive there. Okay. In quadrant 3. Sine, y is a negative, but the radius is positive. A positive over a negative, sine would be negative. Cosine is the x coordinate, a negative, divided by the radius, which is always positive, a negative over a positive. Cosine is negative. Tangent though, the y is a negative value, and the x is a negative value. A negative divided by negative is a positive value. So in quadrant 3, the only positive trig ratio is tangent. Tangent is the only one that's positive. So in the first quadrant, it's all of them. Sine in the second, tangent in the third. Well, we just gonna leave cosine out of it? No. Let's see. Sine theta, cosine theta, tangent theta. Sine is y, that's a negative. The radius is a positive. Negative or positive will be a negative sign. Cosine is a positive. Cosine is a positive in the fourth quadrant. The radius is always positive, and a positive over positive, that's a positive answer in quadrant 4. Tangent, the y is a negative, x is a positive, so a negative over a positive in quadrant 4, tangent has to be a negative. So in quadrant 4, the only positive trig function is cosine. Now, not the only one, but the reciprocals are also going to be following in the same footsteps. All of them are positive in quadrant 1, and the reciprocals also will be positive. Cosecant, secant, and cotangent. Only sine in quadrant 2, and the reciprocal, cosecant theta, is also positive. Tangent and cotangent in quadrant 3 are both positive. In quadrant 4, it's cosine and the reciprocal, secant. And this is one of the things that I remember learning is how you help me remember. All students take calculus or take a cooking class, but all of them are positive in quadrant 1. And then as you go around counterclockwise, the sine ratio, only sine is positive, only tangent is positive, only cosine is positive. Because the sign, SIGNs, are gonna matter. And I emphasize that all the time, and it's the first thing you want to do is what's your sign? Is it positive or negative? Or positive. And people don't take care of those little tiny little things. And you lose silly points, and you shouldn't have to lose silly little points. So let's take a look at an example. You had to do this on your last quiz. You were given like cosine theta was, I'm just going to make up a number of 5/8. And then you find the other, 5 trig functions, find all 6 trig functions. But you were in the confines of a right triangle. Now you're going to be given something like this. Let's take a look at an actual homework question. Number 15. And on 15 to draw a picture for it. Let's do our own. Let's do number 20. I like 20. Let's go for it. It's just like 13, 15, and 17, except they don't draw any picture. It says the point is on the terminal side of an angle in standard position. So this point, negative square root 21, comma 2, that's on the terminal side of an angle that's in standard position. Determine the exact value, so no decimal, of all 6 trig functions. So all you're given is this ordered pair. Negative square root 21, comma 2. For the 4,387th time, and probably not the last, draw a blended picture. Picture's going to help you. It's going to also trigger the things you need to make sure you pick up. What quadrant is that point in? That's in quadrant 2. You got to fill in sine of theta, cosine theta, tangent theta, secant theta, secant of theta, and the cotangent. So quadrant 2, and you don't have to be that specific. Somewhere to the left is negative square root 21, and then you go up 2. And so that's the terminal side of the angle that opens up like that. Now, when I say draw a picture, that means make it a triangle. That might help as well. The triangle that you make is always with the x-axis. And you want to make sure that you remember just starting with sine theta, it's the y coordinate over the radius. You know what the y is, but you don't have the radius. The cosine of theta is the x coordinate over the radius. You know what the x is, but you don't have the radius. And the tangent of theta is y over x, so you could actually do that and get cotangent, but you still got to do the others. The fact of the matter is, it makes a right triangle. The blue, the height, that's a 2. Now, because you're going to use Pythagorean theorem, I try, when I make my triangle, I stay away from using the negative. I know it's going to be over here, but the length of this side is just square root 21. So how do I make sure I remember to put negatives? I do this. What quadrant is that angle terminating? 2. The only positive trig ratio in quadrant 2 is which one? Sine. So that means right away, you're a negative, you're a negative, you're a negative, They're negative. No offense, they're all negatives. They're all negatives. And then everything else from there, the other two are positive, and I just get my numbers. Okay. So 2 squared plus the square root of 21 squared is equal to that radius squared. So square root of 21 squared is just 21 equals the radius squared. 25 is equal to the radius squared. Take the square root. The radius of this is a 5. So y is 2 over 5. So cosecant is 5 over 2. Cosine is the x, negative square root of 21, or in this case, the negatives over here, square root of 21 over the radius, which is 5. So secant, flip it, 5 over square root of 21. And then the tangent is the y over the x, negative 2 over square root of 21. So this is square root of 21 over 2. But you got to take care of your signs. You got to know to make sure you take care of your signs. Let's take a look at number 35 right In 35, we're told that the secant of theta was equal to -2, and the constraint 0 is less than or equal to theta, which is less than or equal to pi. So that's right. Find the values of all 6 trig functions. Okay. Find the exact value of all 6 trig functions. So sine of theta, cosine theta, tangent theta, cosecant theta, secant of theta, cotangent of theta. Again, my brain doesn't, I can do this with this. I know this. Don't forget to get this one right. But my brain does not process secant information. It processes sine, cosine, tangent really well, but not secant so well. If I know secant, I also know cosine. What's cosine? -1/2, the reciprocal, flip it over. So if you know that this is -2, then this would be -1/2. Okay, so that means we got cosine, a little better to work with. Cosine theta is -1/2. Don't forget about the constraint, because that's telling you what quadrant it's in. Sometimes they'll come right out and tell you, Theta terminates in quadrant 3. Beta terminates in quadrant 2. Beta terminates blah, blah, blah. They're telling you beta is somewhere between 0 and pi radians. So when I draw a picture of this, the pictures help. From 0 to pi, 0 to pi is quadrant 1 to quadrant 2. What quadrant does theta have to terminate in if cosine is negative? In quadrant 2. That's the only possibility. It can't be quadrant 1 because in quadrant 1, cosine has to be positive. And it's not. So it has to terminate somewhere here in quadrant 2. So I'm just going to draw a little angle here in quadrant 2. Now I know that this is x over r. So the x as a ratio would be 1 and the hypotenuse would be a 2. Or the radius would be a 2. To do the sines and tangents, I need to know the y. In case you don't see it, you probably figure it out. If you don't see it, I need to figure out what y is. So y squared plus 1 squared equals 2 squared. Y squared plus 1 equals 4, subtract 1. So y squared is a 3, take square root. So y is square root of 3. Oh yeah, well, this side is half of the hypotenuse, that must be 30 degrees. And this is square root of 3 times the short leg, so that must be 60 degrees. So technically, you're talking about the cosine of 120 degrees. That's what you're actually taking. Because it's always measured from standard position. But we don't care about that. We just need to know where our x's and y's are. The ordered pair up here, x is a -1 and y is a positive square root of 2. Not that you have to put that because the triangle helps you. Sine, the y is square root of 3, and the radius is a 2. So this is 2 over the square root of 3. The tangent in quadrant 2, oh man, I should have put my negative already. Cotangent would be negative. But the tangent would be the y over the x, square root 3 over 1. So just square root 3, negative. And then 1 over square root 3, negative for the cotangent. If you know one, you know them all, provided you know what quadrant. This page right here, page 422 in the book, is when you do on the page right there, if I go to print, okay, and I say, all right, I just want to print the current page, I'll make just basically that page, and I'll just, instead of printing it, I'm just going to do a PDF. So that way I save that page as its own special page, because that page on the reference angles is a really special page. So I got that page really pulled out over here. Reference angles. You have to know every single angle all the way around the circle because we've done them already. 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 360, 315, 330, wait, that's one. 270, 300, 315, 330, then back to 360. And then you got to go radius. 0, power 6, power 4, power 3, power 2, 2 power 3, 3 power 4, 5 power 6, 5, 7 power 6, 5 power 4, 4 power 3, 3 power 2, 5 power 3, 7 power 4, 11 power 6, and then back to 2 pi. Okay, you gotta know everything. Okay, you gotta know that, but I gotta know that better than I know my wife's birthday. Oh, wait. The next one. Or I just need to know quadrant 1. 0, 30, 45, 60, 90, because it all maps over. They're all reflections of each other, the same numbers everywhere you go. If you know 1 in quadrant 1, you know them all in all the other quadrants because the order pairs are just positives or negatives of each other. Quadrant 1 is the key. That's where reference angles are. You're going to refer whatever angle you have to an angle in quadrant 1. So, the reason why I saved this page, pull it out from the rest of them, because let theta be the angle in center position, any angle you want. Its reference angle is the acute, which means quadrant 1. The acute angle, theta prime. So the given angle, you have some angle theta, who knows what it is. The reference angle is theta prime. Okay, prime like back to the beginning. And that reference angle is going to take us back to quadrant 1 where we know everything by heart. And it's formed by the terminal side of the angle where it ends, and the horizontal axis, the x-axis. You never make a reference angle with a y. You always make reference angles with the x. So, the good news, if your angle terminates in the first quadrant, the reference angle is itself because you're in quadrant 1 angle. So 72 degrees, the reference angle in quadrant 1 is 72 degrees because you're already in quadrant 1. But when you're in quadrant 2, now try not to memorize. Try to picture or try to know. Knowing is better than memorizing. When you have an angle that terminates in quadrant 2, so somewhere between 90 and 180, between pi over 2 and pi radians. The reference angle is this much. That's the amount. So if this was 110 degrees, the reference angle is how much does it make with the x-axis, with the horizontal axis. So to figure it out, that difference in between, you take 180 degrees and you take away the 110 degrees. So the reference angle is 70 degrees. That's how much further you would have to go down to get to the 180. We'll take it down to 99. I should write that. 180 minus the reference or the original angle. If it's in radians, if this was 4 pi over 5. It was 4 pi over 5. Well, this is pi down here. The difference in between is pi minus the given angle, 4 pi over 5. So what's in between? 1 pi over 5. There would be 1 pi over 5 in between. Okay. But then you get over to here. when we're in quadrant 3. In quadrant 3, the angle's bigger than 180. So it's bigger than 180. So maybe this is 215 degrees. You want the measurement of the angle to the x-axis. Now the x-axis, that's 180. So the difference in between is 215 degrees minus the 180. That's 35 degrees in between. So the reference is that 35-degree angle between. Over here, it was 180 minus the 110, and over here, it's the 215 minus the 180. We'll make up the number. It depends on what quadrant you're in. Do you go 180 minus the angle or the angle minus the 180? It depends on what quadrant you're in. Is it bigger than a semicircle or less than a semicircle? That's why I say draw. Sure. Know what quadrant you're already in. I need to see it. I'm visual. I don't know what quadrant I'm in. I just need to see it. Okay. When you're in quadrant 3, you're past the 180. So to find the difference, you subtract 180 from the given angle. Over here, you're not far enough. So to get a positive reference angle, 180 minus how much you're short. And then when you get into quadrant 4, the x-axis is at 360 degrees or 2 pi. So if this angle right here is 309 degrees, then how much are we short would be 360 minus 309. So we're short 51 degrees. And that's the reference to the x-axis. It's all about going to the x-axis. That means I don't, in a book, if we had to do this the old way, they wouldn't have sine, cosine, or tangent for 309 degrees in the back of the book. You would only have 0 to 90. Because you would need to know I'm in quadrant 4. The only one that's going to be positive is the cosine. So if I'm looking up sine, and you put negative in front of it. I'm looking up tangent, you put a negative in front of it. But then I would look up the sine of 51 degrees and have a negative in front of it. Or look up the tangent of 51 and put a negative in front of it. Because the sine or any of the 309 is not going to be back there. Or if you're going to put 309 back there, you got to put every angle that exists in the back of a book, and you can't have that. It just goes 0 to 90. And that's all we need to worry about. And that's because of the reference angle. The reference angle will sit it back to the first quadrant. So let's practice finding the reference angle. Let's go home. Even the homework says draw sketch. Find the reference angle theta prime for the special angle theta, sketch theta in the standard position, and label theta prime. So let's see. Let's do. Let's do 55. Let's do 57. Let's do 51. $63 and $69. 55 and 7. So sketch the angle, stand in position. Theta is 45, negative 45. So that means you need to open up clockwise from standing position. So standing position in that way. And then negative 45 would be like this, negative 45 degrees. So there's theta. Theta prime is the angle that it makes with the x-axis, the positive angle. So how much angle is in between the x-axis and that termination of angle? Positive 45 degrees. Theta prime is 45 degrees. That's all. On 57, theta is 5 pi over 3. So if you're not, just by looking at it, if you don't have your unit circle right in front of you, 1 pi over 3, then 2 pi over 3, 3 pi over 3 is 180, 4 over 3, and then over here, there's 5 over 3. So if that's 5 pi over 3 in center position, then the reference angle is this much. Now, here's the good news. You don't need to do and show the work if you know it by heart. That's what I hope you know by heart. If this is 1/3, 2/3, 3/3, and this is 4/3, this is 4/3. But in blue, this is 5 pi right here. There's 5/3, then this must be 6/3. So how much is missing right there? It's 1/3. The reference angle theta prime. Messy. Theta prime is 1/3 pi over 3. That's all. Okay, that's it. But now comes the thinking. Not so much on degrees, but radians bite you every time. So 63, 208. What quadrant is 208 going to terminate? Which one? In the third. So remember, 180, that's 270. So it's between 180 and 270. So it's over here. 208 degrees. So if that's 208, your reference angle is right here. There's theta prime. So if the whole thing is 208 and you know that's 180, to get theta prime, you just got to go 208 and take away the 108. So you have 28 degrees missing. So the reference angle theta prime is a 28-degree angle right there. So now if I was going to be in the, go back, 55 years, 60 years, kind of look in the back of the book at the table, I can't look up 208 degrees, but I can look up 28 degrees. And if I needed the sine of 208, I would use negative sine of 28. Because 208 is in quadrant 3, the sine would be a negative value. Okay. 69, theta is 1.8. 1.8 what? That's radians. And you know it's radians because there's no degrees in it. That's the only way to tell. If there's no units given at all, you're told it's an angle. It's in radians. If you want, if they need to tell you degrees, it has to have degrees. So now I need a picture. What quadrant would 1.8 radians terminate? Which one? Quadrant 2. Because we know this is pi, so that's approximately 3.14 radians. So that's smaller. 90 is pi over 2. Straight up here is not pi over 2. If I take 3.14 and divide by 2, this is approximately 1.57 radians as a decimal. So 1.8 is in between 1.57 and 3.14. So the 1.8 would be right here in quadrant 2. So that means my reference angle is on this side right here with the x-axis. So you need to find this amount of opening, and you're going to take pi minus that 1.8. Now, that's the exact answer. I would stop there if I was doing any work. I don't know if they want you to look in the back to see if they want more decimals. They actually want you to punch it in or not, but that's the answer. That's the most accurate answer you're going to get. But that's how you would do it. Because it's in quadrant 2, this amount of opening for theta prime is the whole, pi, and you're missing that 1.8 for this part right here. That's your theta prime. Okay. What have I been doing? Evaluating the trig function of any angle. To find the value of any trig function for any angle. What's the answer for the reference angle? You look at the reference. And then you decide about the quadrant. You can only look up reference angles, or not that you have calculators, what you do, but you can punch it in, you just punch it in. But reference angles, it's all about reference angles. And it's going to be really important because when we teach you how to take the sine of 372 degrees, or actually, sine of 500. The sine of 352. Quadrant 4, that's going to be a negative. Okay, just punch it. But when we say that the sine of a theta is equal to negative 0.73897, and you have to solve for all possible answers for theta, it's the reference angle that is going to tell you how to get all your answers. It's a lot simpler because if you just hit inverse sine of negative point whatever, it's not going to give you the correct answer for what you're being asked for. And when we cross that bridge, we will definitely get there. But the calculator is not going to do it for you. You're going to have to think. So the way I teach it is reference angle. It's about the reference angle. Okay? So now what I want to give you, and I'll post it as well, but I'm going to give you this handout of what it all goes back to. The color unison. This has everything that we do with respect to our special angles. That's enough. But as you go around the circle, you're 30 and you're 150. 30 is the reference for 150, pi over 6, 5 pi over 6, that's the same thing. Root 3 over 2 is the x, negative root 3 over 2 is the x. Y is 1/2, y is 1/2. The y's are the same, sine is the same sign. Cosine is different because the x's are different signs. In quadrant 3, they're both negative. So sine is dependent on the y's, so the y's negative, sine's going to be negative. Cosine is dependent on x's, since x is negative, cosine is negative. Tangent is y over x, negative over negative. In quadrant 3, you're going to get a positive for tangent. X is positive in quadrant 4. Cosine is positive because cosine is x over r. Sine is dependent on y's. Y's are negative. And the y's are the same y's up there. The reference angle for a 300-degree angle, because that's 60 degrees here. The reference angle is 60 degrees up there. 1/2, that's a 1/2. Positive root 3 over 2, that's a negative root 3 over 2. Okay. I'm going to see one more up there. We'll pass it up a button. But I'll post it up as well. Same for today, for today. You know, 1 point or 5.3 is not done yet. The last one is this. So you have this, you now have your unit circle in front of you. And like I've been saying, it's all about quadrant 1. So 0 through 9 is in quadrant 1. If you know this, you know everything you need to know. So your radian doesn't go all the way through, but at least you know this much. In radian, 0, pi over 6, because it's 1/6. That's 1/4 of a pi, so pi over 4. That's 1/3 of a pi, so pi over 3. That's 1/2 a pi, pi over 2. The 60 increments of 60 are always thirds. The 45 degrees are always fourths. They always have a 4 underneath. The 30-degree increments, except for the ones that have 60, because the 30s always have, you know, a 6 at 150, at 30, at 210, at 330. Sine. Y over R. Now the ordered pair at 0 is x is 1, y is 0 on the unit circle. So y is 0 and the radius is 1. 0 over 1 is 0. So that's something we hadn't actually hit yet, was the sine, cosine tangents for the 0, the 90, the 180, the 270. Cosine is the x over the r. Well, over here, x is a 1 and the radius is what? So x is 1, radius is 1, 1 over 1 is cosine to 1. At 0 degrees, tangent y over x. The y is a 0, the x is a 1, 0 over 1 is 0. And then your reciprocals. If you take the reciprocal of 0, because this is 1 over sine theta, or r over the y. This is going to be undefined. If you take the reciprocal secant, take the reciprocal of cosine, 1 over cosine theta, or r over x, reciprocal of 1 is 1. And then for cotangent, that's 1 over tangent theta, or the x over the y. Well, now you've got the reciprocal of 0 undefined. And then we're at 30. The x is a square root 3 over 2, and the y is a 1/2, and the radius is a 1. So 1/2 over 1, sine is 1/2. The cosine is x over r, square root 3 over 2 divided by 1. So square root 3 over 2. The tangent is y over x, 1/2 over square root 3 over 2, so that's 1 over square root 3. Or if you rationalize, square root 3 over 3. And then you do your reciprocals. The cosecant, reciprocal of 1/2 is 2. The secant, reciprocal of root 3 over 2 is 2 over square root 3. Again, if you rationalize 2 square root 3 over 3, you don't have to. And tangent, the reciprocal would just be square root 3. At 45, it's isosceles. X is square root 2 over 2, y is square root 2 over 2. So that means this right here, y over 1 is square root 2 over 2 divided by 1. X is equal to it, square root 2 over 2 divided by 1. And then since x and y are equal, tangent is 1. Also acceptable, just in case, because we've done it before. This is the same as just good old 1 over the square root of 2. Cosecant, you flip over root 2 over 2, and this is acceptable, 2 over square root 2. If you rationalize it, you would just get square root of 2. Secant's going to be equal to that. You would flip it over and you would get 2 over square root 2 or just square root 2. And the reciprocal of 1 is 1. 30 and 60 are complementary angles. The sine of 30 is the cosine of 60, and the cosine of 30 is the sine of 60, because one's opposite is the other one's adjacent. So if you know the cosine of 30, that's going to be your sine of 60. And if you know your sine of 30, that's going to be your cosine of 60. Or if you just draw a quick picture, at the 60 degrees up here, up here, the ordered pair, x is short, 1/2. The y is your square root 3 over 2. That's longer. That's the long one. So the sine, square root 3 over 2. The x is now shorter. It's the 1/2. Sine of 30 is 1/2. Cosine of 60 is the 1/2. The tangent, the y over the x, square root 3 over 2 divided by 1/2 is going to be your square root 3. And then you flip them. This would be 2 over square root 3 or 2 square root 3 over 3. Flip over 1/2 and you get 2. Take the reciprocal of square root 3 and you get 1 over square root 3 or square root 3 over 3. And then the last but not least, at 90, right up here at 90, x is 0, y is 1. So the sine of 90 is the y over the radius, which is still 1. 1 over 1, the sine of 90 is 1. Cosine is x over the radius. 0 over 1 is 0. And as I showed you earlier, the tangent at 90 is y over x. 1 over 0 is undefined. And then the reciprocal function, the cosecant is the reciprocal of 1, so that's a 1. Secant is the reciprocal of 0, or the radius over x. If the x is 0, the radius over x is going to be undefined. And then cotangent. Remember, this happened because it was 1 over 0 to get us undefined. So the cotangent would be 0 over 1, so this is going to be 0. If 1 is undefined, the reciprocal is 0, and vice versa. That's the node. I got a node. Okay. I'm going to give you this because it's going to go all the way around the circle. It's the same answers, but are you going to put it in the right SIGN, the signs? So it covers all the way 0 to 360. It's not homework. This is like, I want to do well. You can use anything you want for the quizzes. Quizzes are free. Anything is up for grabs. As long as it's not an internet device and you're dialing up, the math side. I'm thinking of a number. Everybody's here. That's a good day. You guys have a good weekend, and see you on Monday unless I see you in office hours. Oh, you get, my bad. It's good. I'll make the trip around the block and I didn't.